So I wanted to record the second half of these notes. We did this. We started the Mold Day 2 yesterday. We made it through talking about the idea of masses and figuring out molar masses, and we kind of finished up right here. We did calcium hydroxide and sugar together, and then your homework last night was to figure out the molar mass of the other four compounds. I would like to go through the remainder of these notes here and then give you guys the day 2 homework to complete today. Now, I know some of you may not have the worksheet with you, and that's okay. These problems you can do them on a piece of notebook paper. As long as you show me the work, I'll give you credit. And then when we get back into school, it's a quick, page of notes just to copy into the rest of your notes so you have it all together. What I would like to, like I said, what I'd like to start with is just finishing these notes off. We'll get numbers down and answers to the couple of blanks. I'll show you how to do the problems, and then I'll set you free to finish these off. If you have any questions, then please send me a message today, and we can sit down and talk. But to finish the notes, the first thing that we need to know, it says, if we know the mass of 1 mole of water is blank, what would the mass of, say, 2 moles or 5 moles or half of a mole of water be? Well, at the end of yesterday, like I said, your homework was to do 1, 2, 3, and 4 on this page. So theoretically, right now, everybody should have the molar mass of water figured out. But I'll do it here real quick just so that we know. We said the first step is to list out the elements that are in the compound, hydrogen and oxygen in this case. We need to know the number, how many of each are in the compound. So for hydrogen, it's obviously 2, and for oxygen, it's 1. We need to multiply those by their masses. And we get their masses from the periodic table. Hydrogen's right over here, 1.01. Oxygen is 16. Like I said yesterday, you guys can round those numbers. I'm just going to use 1 for hydrogen. Obviously, we don't really need to round 16. And then we multiply. 2 times 1 is 2, 1 times 16. And we add up our total. So it's 18 grams per mole for water. We take that number and let's put it down here. So we got 18 grams. And then it says, what would the mass of, say, 2 moles of water be? And hopefully it makes sense. All we have to do is multiply that by 2. 36, not 26. 36. Well, if we want to know the mass of 5 moles of water, we would multiply by 5. 5 times 10 is 50, plus 40 is 90 grams. If we want to know half of a mole, we cut this number in half. This 18 gets cut in half. That's 9. So we're going to try to figure this out. We're going to show the work, kind of doing the same, dimensional analysis or factor label method that we've been doing, using our steps for these example problems down here. But to fill this in, we're going to figure out we can determine the molar mass for any compound by using the molar mass. And then converting using a conversion factor. So let's run through these 3 example problems, and then like I said, I'll end the video there. You can send me a message later if you look at this and need any help. It's the same process for all these. We're going to do our circles and our squares and our arrows, and then we'll set up our problems. So in this question, what is the mass of 6 moles of nickel atoms? It's asking us what's the mass. So it's giving us 6 moles, and we need to convert to mass. Now be careful. We've been converting to numbers of atoms before. You have to really focus and make sure you're reading what the question is asking about. In this case, it's asking about the mass, so that's where we need to get to. Whatever we circled, 6 moles, put that over 1. And then we set up our conversion factor. If moles is on top, it goes down to the bottom. On the top, we need to put the mass, but remember when we create a conversion factor, we're using units. So I don't want to put mass here, right? I'm not going to convert to 10 mass. It doesn't make sense. We need to convert to our unit. In this case, the unit for mass, as we can see up here, each time is grams. Now, what are the numbers, right? What we've been calculating on this page up here are molar masses. So this would be 18 grams per mole, really. But what that's actually saying is that, well, for water, in this case, 1 mole is equal to 18 grams. It's an equality. Now, remember, it changes. The mass of different elements is different. So we have to make sure that we focus on what it's actually asking us about. In this case, it's nickel atoms. So I'm going to say, okay, let's go to the periodic table. Let's find nickel. Nickel's right here. 58.69 is its mass. So for nickel, 1 mole of nickel atoms is equal to, let's round it up, let's just say 59 grams. This equality is what we can use here. Mole always gets a 1, and in this case, we do 59. Get my trusty calculator out. Should be what? 354. 6 times 59 is 354. Moles and moles can cancel. The only unit that's left is grams, so that is our unit. In the second one, okay, so now it says if we have 48 grams, so we're given grams this time, and it's asking us how many moles. So once again, we're going in the opposite direction, so we're going to do the opposite mathematically. We're probably going to have to divide here, which makes sense. But if I take that given, 48 grams, put it over 1, and set up my conversion factor. Well, this time grams goes to the bottom. We need moles on top, and I need to know my mass. We've used oxygen quite a few times. Its mass is still 16. So 1 mole of oxygen is equal to 16 grams. There's our equality. Let's put our numbers in. Mole always gets a 1. Grams gets a 16. We can show this multiplying across if you'd like. I like to just take the top number divided by the bottom number because that's what we do ultimately. But if I do 48 times 1, it's 48. 1 times 16 is 16. And then we divide those two numbers. 48 divided by 16, I believe, is 3. Put our unit on, moles, and we're done. For the third one, it adds kind of one little layer where instead of just giving us a particular atom like oxygen or nickel in the first two, it gives us a compound, sugar. But that's okay. If we have the formula, if we know the formula, we can figure out the mass. Gives us 4.6 moles. It wants to know mass. We got to go from moles to mass. It's going to be similar to the first one. So 4.6 moles over 1. And then we multiply. Moles to the bottom. Our mass should be on top, so grams. But now we need to figure out the molar mass. I can't just look at the periodic table and figure it out right away. I have to do the molar mass problem like we had done up here. Theoretically, everybody should have this one done already. I don't. So I'm going to do it down here kind of as like a little side problem. Same deal. I'm going to list my elements. The number is, 12 and 22 and 11. We multiply those by their mass. Carbon from the table is also 12. Hydrogen's 1, oxygen's 16. Remember, these numbers coming right off the periodic table, 12 and 16 and 1. We get 144, 22, 176, and then we add them up. And I believe our answer was 342 for this. This number is what we're going to throw right here. 342 grams for every mole. Both numbers are on top, so I multiply them. 4.6 times 342. I'm getting 1573.2 grams. So that hopefully will get you guys rolling in the right direction. Like I said, I would like you guys to finish the problems at the bottom here. For all of them, I've given you the answers. Right? I like to do this when we get to chapter 10, just like in chapter 3, just so that you can kind of be guided and go through. You know, if you're doing the question right at the end, if you get that answer, please don't just write words down and then put my answer. Give it a shot on your own. I'll post this video as well as the worksheet in case you guys want to look on the worksheet. Please let me know if you have any questions. Have a great day and be safe.